times net book value over 100.
Times net book value over 100. Please quote the
Yes.
can you quote the formula so that I write it on our screens? So formula for calculating what exactly?
So the reducing balance method.
The rate. Oh, okay. So what formula did he give for
No,
calculating
not
the?
the
Okay, not the rate, but as in
the
calculating the
reducing
depreciation.
balance method. Yes.
Okay, so quote the formula. So according to that formula, depreciation is equal to what?
The rate times the net book value over 100.
Okay. I think I get it. The rate times the net book value, all divided by 100, right? Yeah, I think
Yes, please.
yes. You don't be confused about that. I'm sure it's a matter of interpretation. Let me do that for you. So if I have this all divided by 100, see, what it simply means is that if the rate is 10%, I'll put 10 here and multiply by the net book value and divide by 100. So technically it's not wrong, just a matter of, how you explain it. Okay. So for instance, if we are to apply it to this question that we just solved, this is how it's going to look like. So it's going to be, the depreciation will be equal to 10 times the net book value. In this case, let's go to the second year. Okay, so the second year, the net book value would have been 45,000, right? So it will be 10 times 45,000, all divided by 100. Okay, because the rate is in percentages. So if it is 10%, it is 10 divided by 100 times the net book value. So the formula is not wrong. I'm sure it's how it is presented. Suggest you. So let's do it anyways. So we clear that confusion. Okay. So if we had gone it or done it this way, then we'd have 10 times 45,000, which would be 450,000 divided by 100. And I want to believe we would get 4,500, right? So it's the same thing.
Yes, please. Okay.
Like we did here, we just multiply the rate 10%, and 10% is the same as 10 divided by 100. So no confusion there. Thank you very much. Anyway, I appreciate the contribution you made there. That's why I'm here. We are here to clear confusions. If you are confused about something, please don't hide it.
Yes, please. Thank you.
Thank you too. So let's move to the third one, which is sum of years digit. This method is very interesting and very sweet, but it can be very stubborn if you don't grasp the principles well. Okay. In fact, I don't know, but ordinarily I don't stress on this topic. But because every mark counts in examinations, that's why. Because you can have an objective test question where you have to do this. So let's go through. Now, under this method, a fraction is computed, okay, by dividing the remaining useful life of the asset on a particular date by the sum of years they get. I don't want you to get confused. Let's go straight to how to calculate the depreciation. Under the sum of years they get, if you want to calculate depreciation, you need this. You need the remaining useful life of the asset, and then you need the sum of years they get. Okay. Now, all these two variables you need can be determined focusing on the useful life of the asset. Okay, so there's a simple formula to get the sum of years they get. which is n in bracket n plus 1 divided by 2. Now, let me cite an example so that it makes sense. So if the useful life of the asset is 5 years, then sum of years digit means that you add, because 5 years means 1, 2, 3, 4, 5, right? So the sum of years means add the 1 to the 2 to the 3 to the 4 to the 5. What you get is the sum of years digit. So if the useful life of the asset is 10 years, it means you have to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay. So imagine if the useful life is 30 years, you have to add 1 plus 2 plus 3 to 30. So it becomes a bit crazy. That is why this method is there for us to assist us. Okay. But if the year is not too long, you can do the plus 1 plus 2 plus 3 plus 4 in that order. Okay. So that is how you calculate the sum of years. So let's do a quick example down here. So let's say the useful life of an asset is 5 years. If you put it in this formula, it's going to be 5 outside the bracket, 5 plus 1. And I think that should be 5 plus 1 is 6 times 5 is 30 divided by 2. The answer is 15. So the sum of years for an asset with a useful life of 5 years is 15. If you go the other way I was talking about, then this is how you do it. It will be 1 plus 2 plus 3 plus 4 plus 5. And let's see if we are going to get the same figure. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is what? 15. Okay. So are we okay with how to determine the sum of years? I want to believe so. Now the next variable is the remaining useful life of the asset. The remaining useful life of the asset, which is also very simple to do. But if the useful life is longer, you find difficulty, right? So please look at how you go about it. Yes, Professor.
Sir, please, sorry, I'm a bit lost with the sum of years digit. Can you please go back?
Okay. So I'm saying that for the sum of years, listen to the name, sum of years. So it's like sum means add the years. So if the useful life of the asset is 5 years, okay, it means add year 1 to year 2 to year 3, year 4, year 5. So add the years. So if the useful life is 5 years, 1 plus 2 plus 3 plus 4 plus 5, you get what? 15, right? Let's say the useful life is 6 years. Then your sum of years will be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Let's do that calculation and see what we get. 3, 6, 10, 15, 21. Okay. If the sum of years, the useful life is 10 years, then the sum of years will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So you are adding the years. Should we do this one too? Let's see. 3, 6, 10, 15, 21, 28, 36, 45, 55. I want to believe my maths is on point too. Okay. So that's how you calculate the sum of years. But the point is, imagine if they give you a useful life of 20 years. So you are going to start adding 1 to 2 to 3, 4, 5, 6. It's very long. So use this formula. Okay. And the formula is giving us n outside a bracket n plus 1, all divided by 2. This is the simple formula to get the sum of years if you don't want to go through the 1 plus 2 plus 3 plus 4 saga, right? So let's apply this the formula to what we have done here. So if, for instance, the first one, the useful life is 5, you put 5 here, 5 here, and when you do the maths, you are going to get 15, which is equal to when you do the +1, +2, +3, +4, etc. If it is 6 years, then n becomes 6. So let's put 6 in place of n and see what we get. So we have 6 plus 1, which is 7. 7 times 6 is what? 42, right? Divided by 2 is equal to 21. Okay. So the formula makes it easier, especially when the useful life is longer. So imagine 20 years. By the time you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. See, I'm even tired. So you just put it in the formula. N is 20. So 20 outside, 20 plus 1. You do your math and get the sum of years. So Prof. Ella, that is how you go about the sum of years. Okay.
Okay, thank you.
Any confusion? Anybody else who wants me to explain further? Good. So that is for the sum of year. When you get the sum of year, you need the remaining useful life of the asset. Okay. And you can determine that when you are calculating the depreciation for a particular year. So let's do an example. Let's use the 5 years. Useful life is 5 years. So if the useful life of an asset is 5 years, it means that the asset is going to be in the business for year 1, year 2, year 3, year 4, year 5. Okay. So now the question is, in year 1 or in the first year, what is the remaining life of the asset? And this one, I'll use your SHS whatever term to help us understand this. You are now in Form 2, right? And your useful life in SHS is 3 years. You are supposed to finish in 3 years. So your useful life is 3 years, if it makes sense. So if you are in Form 2, which is year 2, what is your remaining useful life in SHS? Or as a matter of fact, how many years left for you to finish? It becomes difficult when you just look at it without doing what do you call it? A simple thing we are coming to do together here. Okay, so let me do this. So in your first year, when you entered Form 1, if I asked you how many years do you have to finish school, you would have told me 3, isn't it? In your second year, how many years left? You would have said 2. And then in the final year, you would have said 1. So if the useful life of the asset is 5, then in the first year, the remaining life is 5. In the second year, the remaining life is 4. In the third year, the remaining life is 3. In the fourth year, the remaining life is 2. In the final year, the remaining life is 1. Don't overthink. See a simple thing I'm doing here. I have just descending order. I have just rearranged the years in descending order to the point where the first year corresponds to the last year in that order. That is how you get the remaining life. So if you are given a question and you want to find the remaining life, just arrange the years from year 1 to the last year and then rearrange it in a descending order like I've done here. So 5 years, 1, 2, 3, 4, 5. The remaining life, you just turn it upside down. Okay, so if they ask you to find depreciation in the third year, you know that the remaining life is what? 3. If you are asked to find depreciation in the fourth year, you know the remaining life is 2. It looks a bit, but it's very simple. So are we okay too with how to calculate the remaining life? Yes, I want to believe so. There's a formula, but I won't worry with the formula because most of the questions that come, the years are not too long. So you can go through the arrangement and get the remaining life. So quickly, let's see an example. So on 1st January 2002, Fofana Limited acquired a motor vehicle for 200,000. The motor vehicle is expected to have a useful economic life of 4 years and estimated scrap value of 40,000. The company's depreciation policy is sum of years digit. Calculate the depreciation charge for the year 2002, and then B, the depreciation charge for the year 2005. Okay, so let's make it simple. We know the formula to calculate the depreciation, which is the remaining life divided by the sum of year times depreciable value. And I think yesterday we saw this depreciable value, right? It is the cost of the asset minus the scrap value. Okay, so for those of you who were not here yesterday, depreciable value is the cost of the asset minus the scrap value. These two figures will be given you in the question, so you don't have to worry or stress about it. So let's solve this. So we have the cost 200,000, the scrap value 40,000. The useful life is what? 4 years. Method, sum of years digit. Good. What and what do we need? We need the sum of years. So let's calculate the sum of years. We can use the formula, right? N outside, n plus 1 divided by 2. And the calculation is going to end up at 10. So the sum of years is 10. If you didn't use the formula and you went the 1 plus 2 plus 3 plus 4, you would have still gotten the 10. Okay. But you can use the formula and save yourself the stress. So now it is important to, after getting the sum of years, to also get the remaining life. So I'm saying arrange the years. Arrange the years like this. So you have 4 years, 1, 2, 3, 4. Let's get the remaining life along remaining life. So it's a matter of just turning it upside down. So 4, 3, 2, 1. Okay. So let's put specific date because this question gave us some dates. It says the asset was bought in the year 2002. So the year 1 is 2002, right? So year 1 is 2002. 2002. So year 2 will be 2003. Year 4 is 2004. And then year 5 is 2000. Year 4 is 2005. Okay. So we can now calculate the depreciation because we have the sum of years, we have the remaining life at each point. We can now calculate the depreciation. So the first one says calculate the depreciation for the year 2002. So 2002 is the first year. So what you need is, so the depreciation is equal to, the formula says remaining life of the asset. And per what we have done, the remaining life is 4 years. So 4 divided by the sum of years, which we have gotten to be 10. Then we multiply by the depreciable value. And depreciable value is the cost, 200,000 minus the scrap value, which was giving us 40,000. Then we are good to go. We work it out and get our depreciation. Okay, so 200,000 minus 40,000, that should be 160,000. 160,000 times 4 divided by 10. Whoever is ready with the figure can give me. I'm now punching the calculator. So 160,000 times 4 divided by 10. That's going to give us 6,400. And that's the depreciation for the year 2002. Right. The second one is asking us to calculate the depreciation for 2005. So let's do that for 2005. For 2005, the depreciation is equal to, so you need the remaining life, which is 1, divided by the sum of year 10, times the depreciable value, which is the same up there, 200,000 minus, and you are going to get, I want to believe, 160,000 times 1, you get 16,000. So please, for the sum of years, just when you go through the past question, they don't normally give longer useful life, like 10 years, 20 years, 30. No, normally 4 or 5, so that the calculation can be easier for you. So what the key things I need you to note is you need the sum of years, and then you need the remaining life. So just turn the years and rearrange it. You get the remaining life. You can put it in the formula, and this is the formula. I think I've shared the notes on the page, so you can always refer to the formula. So the remaining life divided by the sum of years multiplied by the depreciable value. Okay. So we won't stress much on this sum of years digits. However, if you have any question, please feel free and ask me. Any question on the methods? Straight line, reducing balance, sum of years. Now we are gradually getting to where I'm sure most of the students run away when you begin to prepare the T account for depreciation and all that. Let me find out, those of you who discussed it in school, did you get to that point where you were preparing the provision for depreciation account, the asset account, and disposal account? Did you get to that point? I think Profela and Mami and Ufewa said they did that. They did depreciation. Did you get to that point? Okay.
Yes, please, we did.
Okay. And I'm sure that was where you were saying, this topic part to what's up? Or it was very smooth for you?
In the beginning, it was rough, but it's okay.
Okay, so no problem. We'll go through together here. So bring out any confusion that you may have. Okay, so let me wrap up with the plenty things we have done, because we are zooming into another unique area, which is highly examinable. This has been dropping in WASI and UPTEC. Check the past questions and you would not be disappointed. So it's highly examinable. That's a double entry for acquiring an asset, depreciating it, and finally disposing. But please, please, and please again, the two methods we looked at, which are the straight line method and the reducing balance method, they are very, very important. They are very, very important. And those are the two we are going to be using in our next discussion. So if you have any confusion there, please, let's clear it before we start the double entries. But the key things I want you to always remember is, for the straight line method, the depreciation is fixed. It doesn't change. And you get the depreciation by multiplying the rate given on the cost of the asset. But for the reducing balance, you multiply the rate given on the net book value. Just that in the first year, the net book value is equal to the cost. That's why we said in the first year, you multiply on the cost. But subsequent years, you multiply on the net book value. So, and depreciation under the reducing balance method is not the same. And per the calculations we have done, you see that. It's not the same, they are different. Okay, so let's join the last session and go through the double entry. I promise to make it very practical for all of us. Okay, so let's rejoin the third session and finish up possibly the double entry so that next week we can start solving questions on the double entry for acquiring assets, depreciating it, and disposing it off. But before that, if you have any question, please feel free to ask me now.